Come on, my dears, let us proceed further in chapter number 8. Kindly read this statement of illustration number 12. Read it? Fine. Look. Density of dry air, I just show it by symbol rho A for air, correct? And you know the formula for density, it is total mass upon total volume, correct? In the statement they have given that assume air to be made up of only oxygen and nitrogen. Then how would you find out density of air? Simple. Total mass of oxygen and nitrogen divided by total volume of oxygen and nitrogen. Simple. So mass of oxygen plus mass of nitrogen will be total mass divided by volume of oxygen plus volume of nitrogen. That would be total volume, correct? Total mass upon total volume will give you definitely density of air. Simple? Fine. Now, what do you mean by mass? It is volume into density, correct? Volume of oxygen, I just take it as V into density of oxygen, I have shown by symbol rho O for oxygen, correct? Plus, now mass of nitrogen would be volume of nitrogen multiplied by density of nitrogen. Volume of nitrogen at present is 4 into V because they have given that in the mixture, the proportion of oxygen and nitrogen is 1:4. 1:4, meaning thereby, if volume of oxygen is V, then volume of nitrogen is 4 into V. 4 into V. That's why volume of nitrogen I am writing 4 into V, correct? Multiplied by density of nitrogen, that is rho N, correct? N for nitrogen, divided by total volume. Come on, volume of oxygen, we have taken capital V, and volume of nitrogen, it is 4 times the volume of oxygen, 4 times V. So I am writing here 4V, correct? Because the proportion of oxygen and nitrogen gases are, that proportion is 1:4. 1:4. That's why. If volume of oxygen is V, then volume of nitrogen would be 4 into V. Simple. Now simplify. I can take V and V common. Correct? Inside the bracket, rho O plus 4 into rho N, correct? Divided by V plus 4V, that is 5 into V, 5 into V, correct? Now this V and this V will be getting cancelled, correct? So rho O plus 4 into rho N divided by 5. Simple? Now this rho O I am taking common. Inside the bracket, 1 plus 4 into rho N upon rho O divided by 5. See, just multiply rho O into 1, that is rho O, plus 4 times, come on, this into this, rho O will cancel, so 4 into rho N, 4 into rho N, simple, divided by 5. And now tell me, rho O as it is, into bracket 1 plus 4 as it is, but what is this? Rho N upon rho O means ratio of density of nitrogen to density of oxygen, and that ratio they have given in the statement as 14 upon 16. 14 upon 16. So this ratio is, value wise, it is 14 upon 16. Okay? Simplify. Now this simplification comes out to be 0.9 into rho O as it is. Left hand side is rho A. What does it mean? Come on. Density of dry air is 0.9 times density of oxygen. Okay. Now recall the correct formula given by Mr. Laplace for finding velocity of sound in gas. What was that formula? Last time we had seen V equals to under root of gamma P upon rho. V equals to under root of gamma P upon rho. Remember, what is gamma? It is ratio of molar specific heat of gas at constant pressure to at constant volume. In short, gamma equals to Cp upon Cv. P is pressure, rho is density. Fine. From this formula, you can make out the relation between V and rho. It is V proportional to 1 upon under root of rho. Velocity of sound in gas is inversely proportional to square root of density of that gas. I repeat, velocity of sound in gas is inversely proportional to square root of density of that gas. Correct? Fine. Now from this relation, we can write VO upon VA equals to under root of rho A upon rho O. In short, when it is inverse proportionality, when you write 1 to 2 1, here instead of 1 to 2 1, we are writing OA AO, correct? VO upon VA will be equal to under root of rho A upon rho O. Fine. Now we want velocity of sound in oxygen gas, so make it subject of the equation. Transfer this VA on right hand side. So it is VA into under root of rho A upon rho O. Correct? What is VA? Come on, velocity of sound in air, they have given for dry air, that velocity they have given in the statement 332 meter per second. So this value is right now 332 meter per second multiplied by square root of ratio of density of dry air to density of oxygen. That ratio we can find out from here. Rho A upon rho O, it will be 0.9. Rho A upon rho O would be 0.9. So this inside ratio is 0.9. So square root of 0.9. Square root of 0.9. And that multiplied by 332. Final answer is 314.77. That many meter per second. Correct? So velocity of sound in oxygen gas would be this many meter per second. Got it? Fine. Now let us proceed further in the theoretical part. The next article is very important. It is about principle of superposition. Principle of superposition. Wait. To understand about this principle, you just consider an extremely thin string which is stretched and kept under proper tension. Fine. From both the ends, you produce two pulses. Correct? Suppose both of them are crest. Both of them are crest. One is having amplitude, say 3 centimeter. Another is having amplitude, say 1 centimeter. Correct? And when you produce these two pulses from both the ends, they just propagate towards each other. Correct? This way. Away from the source. Okay? Source for this production of this pulse is this. Source for production of this pulse is this. And away from source, in the medium, they will propagate this way, towards each other. So naturally, when they propagate towards each other, at some position, they will overlap, they will superpose on each other. They will superpose on each other. Fine. Take this as pulse number 1. Take this as pulse number 2. Fine. When this propagates toward the right hand side, this propagates toward left hand side. In short, they propagate towards each other. At some position, they will superpose on each other. And at that time, you will have resultant wave. That resultant wave is of this shape. And in this shape, we find that this resultant displacement is 4 centimeter. 4 centimeter means 3 plus 1. 3 centimeter means it is displacement produced by first wave. Individually, it was 3 centimeter. And 1 centimeter means displacement produced by second wave individually. Correct? So these two are the displacements produced by superposing waves independently. And once you get resultant wave, in that the resultant displacement is found to be vector addition of displacements produced by the superposing waves independently. So here for superposition of two waves, you may write y equals to y1 plus y2. Correct? Suppose it is superposition of three waves, then you may write y equals to y1 plus y2 plus y3. And if it is superposition of n number of waves, then in general, in the vectorial form, you may write vector y equals to vector y1 plus vector y2 plus vector y3 plus dash 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 plus vector yn. This very statement is only known as, this is the mathematical form, and this is called principle of superposition. This is mathematical form. In words, if you require the statement, is very simple. Whenever two or more than two waves superpose at any one particle of medium simultaneously, comma, the resultant displacement produced in that particle is just equal to vector addition of displacements produced by the superposing waves independently. Full stop. This very statement is called principle of superposition. I repeat. Whenever two or more than two waves superpose at any one particle of medium simultaneously, comma, the resultant displacement produced in that particle is equal to vector addition of displacements produced by the superposing waves independently. Full stop. This very statement is called principle of superposition. Last time. Whenever two or more than two waves superpose at any one particle of medium simultaneously, comma, the resultant displacement produced in that particle is equal to vector addition of displacements produced by the superposing waves independently. This very statement is called principle of superposition. Simple? Fine. Now, after superposition, what happened to the original waves? I am showing you. This pulse number 1 was propagating towards right hand side. After superposition, still it continues to propagate towards right hand side with the same amplitude. Correct? Similarly, pulse number 2 was propagating towards left hand side. After superposition, still pulse number 2 also continues to move in the same direction with the same amplitude. Correct? So, pulses maintain their shape and maintain their amplitude, maintain their direction of propagation. Okay, fine. Now, let us take one more example. Suppose from left end we produce crest. Okay? And suppose from right end we produce trough. Suppose this amplitude is 3 centimeter, this amplitude is say 1 centimeter. How much it is? 1 centimeter. But because it is downwards, we take it minus 1 centimeter. Correct? Come on. Individual displacement produced by first pulse is 3 centimeter vertically upwards, that's why it is positive. Individual displacement produced by second pulse is 1 centimeter, but because it is vertically downwards, we take it minus 1 centimeter. Correct? Now, when these two pulses propagate towards each other, they will also superpose. And after that, you will have resultant wave like this, in which this much is the resultant displacement. It is found to be 2 centimeter. And 2 centimeter means 3 plus minus 1. Correct? This is the displacement produced by first pulse independently. Let it be y1. This is the displacement produced by second pulse independently. Let it be y2. So, here also we notice that y equals to y1 plus y2. This is nothing but principle of superposition. Fine. Now, tell me, after the superposition is over, what will happen? The pulses will maintain their direction of propagation of wave, will maintain their shape, will maintain their amplitude. Look, first pulse was moving towards right hand side. Still, after the superposition, it still moves towards right hand side. Second pulse was propagating towards left hand side. Still the second pulse is propagating towards left hand side. Okay. See, first pulse was in the form of crest, here also in the form of crest. Second pulse was in the form of trough, here also second pulse is in the form of trough. Okay. So, in this case, the pulses maintain their direction of propagation, maintain their amplitudes, maintain their shape. Okay. Come on, last time give me the statement of principle of superposition. Whenever two or more than two waves superpose at any one particle of medium simultaneously, comma, the resultant displacement produced in that particle is equal to vector addition of displacements produced by the superposing waves independently. Full stop. This very statement is called principle of superposition. Simple? Fine. Now we go for another very important theory. What is it? Look. Reflection of a wave from fixed rigid support. What do you mean by rigid support? Rigid support is that which does not vibrate at all, correct? In which there is no deformation at all, correct? And fixed means not movable, not movable. It remains at the same position. Okay, fine. Consider this wall as a fixed rigid support. Consider an extremely thin string which is tied with this rigid support and kept under proper tension. Fine. What we do from this end, we just produce a pulse in the form of crest. So we just give half of the oscillation, say up and down this way, correct? Half of the oscillation. And then you will have production of such pulse in the form of crest. And that crest is now propagating towards this fixed rigid support. Suppose this fixed rigid support is kept at origin, and for any particle on the string which is at origin, its x coordinate must be 0, correct? Fine. Now when this pulse is incident at this very particle, at this very position, the situation is like this, correct? Because this wave is made incident, we call it incident wave. Fine. Now, because this very particle on the string is very much fixed in the fixed rigid support, then we know its resultant displacement would be 0. So, resultant displacement produced in that particle under the influence of incident and reflected wave must be 0. Under the influence of incident wave, suppose the displacement is I for incident. Under the influence of reflected wave, displacement produced is suppose R for reflected. And because you say that particle is very much fixed in the rigid support, the resultant displacement according to principle of superposition, it should be Yi plus Yr. But because this particle is fixed in the rigid support, this resultant displacement must be 0. Correct? Fine. That's why I am showing at the time of superposition, I am just showing the string this horizontally, because the resultant displacement produced in this particle is 0. Okay, fine. Now, after the superposition is over, now you will have reflected wave. In which direction will it propagate and with what amplitude? I am showing you. Find out Yr from here. You will get minus of Yi, minus of Yi. So, Yr equals to minus of Yi. The meaning is that if incident wave is propagating towards left side, then reflected wave will propagate towards right hand side. And this minus sign shows that there is a reversal of shape. From crest it will become trough. Earlier it was being made incident in the form of crest. Now it is being reflected in the form of trough. So this negative sign is due to reversal of shape. From crest it becomes trough. Fine. And then after you will have reflected wave propagating towards right hand side this way. Correct? I am writing here reflected wave. What was this? This was incident wave. What is this? Reflected wave. Correct? So what have we noticed in the figure? Whenever any wave is reflected from the surface of fixed rigid support, there is a reversal of shape. From crest it will become trough, or you may say reverse also, from trough it would become crest. If incident wave is made incident in the form of crest, then reflected wave will be reflected in the form of trough. If while being incident the wave is in the form of a trough, then while being reflected it will be in the form of a crest. Crest will be turning to be trough and trough will be turning to be crest. Correct? Crest will become trough, trough will become crest. Got it? Fine. So there is a reversal of shape. This is from physics point of view, correct? From experimental point of view, you will find this. But what is the meaning of this reversal of shape? The mathematical point of view. I am showing you that mathematical meaning also. Look. Incident wave here is made incident towards left side, means in the direction of negative x-axis. So wave is made incident towards negative x-axis. Incident wave propagates towards negative x-axis, and so the equation representing incident wave would be yi equals to a sine of omega t plus kx. Yi equals to a sine omega t plus kx. Last time I told you, if progressive harmonic wave propagates along positive x-axis, then equation for that was y equals to a sine omega t minus kx. And if it is propagating towards negative x-axis, what was the equation? Y equals to a sine omega t plus kx. If the direction of propagation of wave is negative x-axis, then here you must write plus. Remembered? And because this is the displacement caused by incident wave, I am writing yi, I for incident. Simple. But when that wave is made incident at that particle for which x quantity is 0, what would be the displacement? I am showing you. At x equal to 0, just put x equal to 0 here. Simple. Come on, when x is 0, this part would be 0. So yi equals to a sine omega t. Come on, yi is equal to a sine omega t. Correct? But wait. What is y? Resultant displacement. According to principle of superposition, it should be yi plus yr. But because this very particle is very much fixed in the rigid support, resultant displacement should be 0. Correct? Find out yr, transfer this. So it should be minus of yi. Now this minus sign as it is. What about yi? It is a sine omega t. A sine omega t. Wait. This minus a sine omega t, you may rewrite from trigonometric point of view this way. A sine omega t plus pi. A sine omega t plus pi. How? I am showing you. A as it is. Correct? Instead of minus of sine of omega t, I am writing sine of omega t plus pi. Don't you know? Pi plus theta. Pi plus theta means which quadrant? Third quadrant. In third quadrant, sine function is negative. Correct? And moreover, pi means what? 2 into pi by 2. Pi means what? 2 into pi by 2. 2 means even multiple of pi by 2. When multiple of pi by 2 is even number, then sine will remain sine. Sine will remain sine. In short, sine of pi plus omega t would be minus sine of omega t. Sine of pi plus omega t would be minus sine of omega t. Correct? Now tell me. This is the equation representing incident wave. This is the equation representing reflected wave. Now tell me. In the equation of displacement, the bracketed part with periodic function in terms of time would give you phase of the wave. So this would give you phase of incident wave at time t. Phase of incident wave at time t. How much it is? It is omega t. So phase of incident wave is omega t. Correct? Now tell me from here. In the equation of displacement, the bracketed part with a periodic function in terms of time will give you phase of the wave. So phase of reflected wave at time t is how much? Omega t plus pi. Omega t plus pi. Here it is. Omega t plus pi. Correct? Tell me, this phase of incident wave is omega t, and at the same time phase of reflected wave is omega t plus pi. So don't you notice? This phase is greater than this phase by amount pi radian. By amount pi radian. So increase in phase is by amount pi radian. So what does it mean? Whenever any wave is reflected from the surface of fixed rigid support, the increment in its phase is about pi radian. Correct? Whenever any wave gets reflected from the surface of fixed rigid support, its phase increases by pi radian. Simple? Fine. Now extend the same idea generally. Okay, let us see now general meaning of this phase increase in the phase by amount pi radian. See, general meaning is this. Suppose incident wave is represented by this equation, yi equals to a sine omega t plus kx. Now tell me, what do you notice from here? That wave is made incident in the form of crest. That's why here it is plus sign, correct? And because inside there is a plus sign, it must be propagating along negative x-axis. If incident wave is propagating along negative x-axis, then only here would be positive sign. Simple? Fine. If incident wave is represented by this equation, then what would be equation of reflected wave? I am showing you. Instead of yi, you must write yr. Now one thing you know, that crest will become trough, trough will become crest. In short, there will be reversal of shape. So instead of plus a, now we should write minus a. Plus a means crest, now minus a means trough, correct? But if incident wave is propagating along negative x-axis, then you know after reflection, the reflected wave will propagate towards positive x-axis. And don't you know, for a wave propagating towards positive x-axis, here it should be negative sign, correct? So you must just revert the directions of propagation and you must revert the shape, okay? So there are changes in the sign at two places. One is inside, one is outside. Come on. The sign of change inside the bracket is due to change, is due to reversal of direction of propagation of wave. The outside change of sign is due to reversal of shape. I repeat, there are changes in the sign at two places. One is inside and one is outside. The inside change of sign is due to reversal of direction of propagation of wave, and outside change of sign is due to reversal of shape. Here it is made incident in the form of crest. So while being reflected, it will be reflected in the form of trough. That's why I am putting minus a. If incident wave is made incident along negative x-axis, then after reflection it will be propagating towards positive x-axis. That's why here it is minus sign, correct? Come on. If incident wave is represented by this equation, then the equation representing reflected wave you can write this way, correct? Let us take another example. Suppose incident wave is represented by this equation, a sine omega t minus kx. What do you mean? The incident wave is made incident in the form of crest, and while being incident it is propagating along positive x-axis. Fine. That's why it is here negative sign. And now tell me, after reflection what will happen? The crest will become trough. So instead of plus a, you should write minus a. And after reflection, the incident wave, it was made incident along positive x-axis. So after reflection, the reflected wave will propagate towards negative x-axis. That's why here it should be plus sign, correct? I already told you that you have to make changes in the sign. One is inside and one is outside. Inside change of sign is due to reversal of direction of propagation of wave. Outside change of sign is due to reversal of shape. Got it? Fine. Come on, my dears. Now we go for very important theory. It is bit long. I just appeal everybody to pay very nice attention on the screen, please. The title is Stationary or Standing Waves. Stationary or standing waves. Why the name is like this, I'll tell you after some time. Okay, wait. To understand about stationary or standing waves, you please consider an extremely thin string which is stretched and kept under proper tension and tied at both the ends with two fixed rigid supports. Look in the figure now. Here is one rigid support. Here is another rigid support, and here is a string which is stretched and kept under proper tension, whose two end points are tied with two fixed rigid supports, correct? Fine. At this very end, we just assume origin of the coordinate system, and the length of the string is aligned along positive x-axis. Fine. Now for this very particle which is left end of the string, the x coordinate would be 0 because this particle is at the origin, correct? and x coordinate for this right hand side particle, the particle which is located at right end of the string would be this much, that is equal to length of the string, let it be capital L. So I am writing x equal to capital L. For left end of the string, x coordinate is 0. For right end of the string, x coordinate is equal to L, where L is length of the string. Simple? Fine. Now you just assume one particle on the string which is having x coordinates, say equal to x. Fine. Now what we do, we just pull this string from this position, either vertically upwards or vertically downwards little bit, and then we release it, and thereby we are causing some simple harmonic disturbance. Okay. Now when you cause disturbance here, what will happen then after? That disturbance will move away from this source, this way also and this way also. The wave which propagates toward the right hand side will be getting reflected from this right hand side fixed rigid support, and then after it will propagate this way. The wave which is propagating this way will be made incident here, it will be reflected from this left hand side fixed rigid support, and then after it will propagate this way. Then the two waves, one is reflected from this support and another is reflected from this support. Now they will propagate towards each other, and when they propagate towards each other, they will superpose. When they propagate towards each other, they will superpose and they will produce resultant wave. And such resultant waves are found to be producing some stationary patterns in the medium. And because such resultant waves produce stationary patterns in the medium, we call these waves as stationary waves. And in front of our eyes, we find them stationary as if they are standing. That's why we call them standing waves. So such waves, because they produce stationary patterns in the medium, they are called stationary waves or standing waves. The exact definition we will give later on. Wait. So now you just consider the wave propagating towards the right hand side as incident wave, then reflected wave will be propagating towards left hand side. If incident wave is propagating along positive x-axis, then reflected wave will propagate along negative x-axis. Correct? Come on, this is positive x-axis, opposite direction is negative x-axis. I am writing here incident wave, here I am writing reflected wave. Okay? Now tell me, what would you say about equation of incident wave? yi equals to a sin omega t minus kx. Why plus a? Because we say that wave is made incident in the form of crest. Why here there is negative sign? Because incident wave is propagating towards positive x-axis. That's why here it is negative sign. Fine. And now don't you know, whenever any wave is reflected from the surface of fixed rigid support, come on, crest will become trough. So instead of plus a, you should write now minus a. In the equation of reflected wave, you must write here minus a, and because reflected wave is propagating towards negative x-axis, then here it must be positive sign. Correct? Come on. Inside change of sign is due to reversal of direction of propagation of wave, and outside change of sign is due to reversal of shape of wave. Correct? Fine. This is the equation which represents incident wave. This is the equation which represents reflected wave. Simple. Now tell me, when two waves superpose at this very position, what would be the resultant wave? According to principle of superposition, the resultant displacement produced in the particle having x coordinate equal to x would be y equals to yi plus yr, according to principle of superposition. Fine. Yi plus yr means what? This plus this. So it is now this plus this. But when you take this plus this, a and a you can take common inside the bracket. Sin of omega t minus kx minus sin of omega t plus kx. Come on, sin of omega t minus kx minus sin of omega t plus kx. Fine. Now just simplify. A as it is. Don't you know formula of sin of alpha minus beta? Bolo. Sine of alpha minus beta. Come on. Sine of alpha minus beta means what? Sine alpha cos beta minus cos alpha sin beta. Sine alpha cos beta minus cos alpha sin beta. Similarly here, sin omega t cos kx minus cos omega t sin kx. I repeat, sin omega t cos kx minus cos omega t sin kx. Fine. And now here, sin omega t cos kx, but outside it is minus sign. So I am writing minus sin omega t cos kx. Then inside it will be cos omega t sin kx, but outside it is minus. So minus cos omega t sin kx. Fine. And now tell me, sin omega t cos kx minus sin omega t cos kx will be getting cancelled. And now same term is getting repeated 2 times. Okay. So minus 2 times a into sin of kx into cos of omega t. I repeat, same term is getting repeated 2 times. So come on, minus 2 times into a into sin of kx into cos of omega t. Got it? Y equals to minus 2a sin of kx into cos of omega t. Wait. This is the equation which represents resultant wave which is obtained out of superposition of 2 waves which are having same amplitude, same frequency, same wavelength, propagating towards each other and then getting superposed. Correct? Now tell me, this equation, I say, it is not equation of progressive wave. It is not equation of travelling wave. Why? Tell me. For travelling or progressive wave, don't you know the format of wave equation? What was that format? Y equals to a sin omega t plus kx or a sin omega t minus kx. So it is a function of which part? Part like omega t plus kx or omega t minus kx. So any progressive or travelling wave is a function of omega t plus or minus kx. But tell me, do you find such term omega t plus kx or omega t minus kx? Do you find such term here on the right hand side? No. On this right hand side, there is no term which is like omega t plus kx or which is like omega t minus kx. Such terms are not present in the right hand side. Come on. Because it is not a function of omega t plus or minus kx, we can say this wave equation does not represent travelling or progressive wave. Right now, y is not a function of omega t plus or minus kx, meaning thereby present wave is not travelling, present wave is not progressive wave. Correct? Then which sort of wave is represented by this equation? That wave, because it produces stationary pattern in the medium, we will call it stationary wave. So this is the equation which represents stationary wave. Okay? Please remember this format. Y equals to minus 2a sin of kx cos of omega t. Now what does it mean? What is the interpretation of this equation? I am showing you. Wait. Look. We find that in the equation of this wave, the displacement would change periodically as per cosine function with time. Displacement would change periodically with time. And when displacement changes periodically with time, what does it mean? That each particle on the string will perform simple harmonic motion. Correct? Fine. But during that simple harmonic motion, what would be amplitude? I am showing you. Amplitude is nothing but the coefficient of periodic function in terms of time. In the equation of displacement, the amplitude is coefficient of periodic function in terms of time. At present, periodic function in terms of time is this, and its coefficient is this much. Come on, 2a sin of kx. 2a sin of kx. 2a sin of kx. This will give you amplitude of stationary wave. It will give you amplitude of stationary wave. I just show it by different symbol. Different symbol is a dash. A dash equals to 2a sine of kx. What does it mean? That this amplitude of a given particle on the string will depend on its position. For different positions, x coordinate would be different. Depending upon that, this amplitude value will be different. Okay. So here each particle on the string except the two endpoints will oscillate periodically, will perform simple harmonic motion with amplitude depending on its position. Fine. Now tell me, in such a wave, there is no propagation of energy. There is no propagation of energy because whatever energy you have supplied in this medium, that energy remains within the same dimension of the medium. It does not propagate ahead because the wave itself is not traveling. When wave is traveling wave, then you can say energy will be given to the subsequent particles coming along the direction of propagation of wave. So there will be propagation of energy in traveling wave. But this wave is not traveling, it is being stationary in the medium. That's why there cannot be any propagation of energy through such a wave. Okay. Stationary wave does not propagate energy. Stationary wave does not propagate energy. Got it? Fine. Now tell me, if you talk about this right end of the string, then x coordinate is equal to L. But tell me, at x equal to L, this very particle is very much fixed in the fixed rigid support, and because it is fixed in the rigid support, its resultant displacement should be 0. So y must be equal to 0. So at x equal to L, come on, y must be 0. Put these two values at a time in this equation. Come on, put y equal to 0. Y is 0, and that equals to minus 2a sine of k into x. But x equals to L. X equals to L. Put it here. So it is sine of KL into cos of omega t. Now find out sine of KL. It would be 0 upon this would be 0. 0 upon this would be 0. In short, sine of KL in this case would be 0. But tell me, from trigonometry, don't you know sine of n pi must be 0. Sine of n pi is 0. Where n values are 1, 2, 3 dash dash dash. You may have a question why we cannot take n equal to 0 here. I'll show you. Wait for a minute, I'll show you. You put n equal to 1, then sine pi 0. Put n equal to 2, sine 2 pi 0. Put n equal to 3, sine 3 pi is also 0. Correct? In short, right hand side values are same. These functions are same. So these two arguments must be same. This angle must be equal to this angle. KL must be equal to n pi. KL must be equal to n pi. What is K? Wave vector. What is the formula? 2 pi upon lambda into L. That should be equal to n pi. Wait. Pi 1s are pi getting cancelled. Find out lambda from here. It will be 2 into L upon n. Lambda would be 2 into L upon n. Lambda would be 2 into L upon n. And now tell me, can you take n equal to 0? Can you take n equal to 0? N is there in the denominator. If you take n equal to 0, then this wavelength would become infinite. There cannot be any wave with infinite wavelength. So it is, from physics point of view, it is very absurd, meaningless. Okay. Mathematically you may take n equal to 0 here, but from physics point of view right now it is not possible. That's why we begin the value of n from 1 onwards. Correct? 1, 2, 3 dash dash dash. Got it? Fine. As you go on changing value of n, let's say 1, 2, 3 dash dash dash, then value of lambda will also change. So different values of lambda we want to show by different symbols. That's why I'm giving here suffix. Instead of lambda, I'm putting lambda n. N you must write well below lambda. It is called suffix. Fine. Lambda n equals to 2L upon n. Wait. There is one concept here you must understand. What is that concept? Quantization of a given physical quantity. What do you mean by quantization of a physical quantity? The meaning is that if any given physical quantity assumes certain specific values only and cannot assume remaining values, then that quantity is said to be quantized. Here, when you change the value of n specifically, say n equal to 1, then n equal to 2, then n equal to 3, and so on. When you change the values of n specifically, naturally, value of wavelength also will change specifically. So you are going to get only certain specific wavelengths and not the remaining wavelengths. That's why here wavelength is said to be quantized. Is said to be quantized. Wait. Now this is the wavelength for order n. Now here order n is called nth harmonic. N stands for order of harmonic. N stands for order of harmonic. Now what is that? I am showing you. Now tell me, what should be velocity of propagation of wave? According to the formula which we know, V equals to F lambda. V equals to F lambda. Instead of F, I am putting Fn. Instead of lambda, I am putting lambda n. Fine. Now Fn means frequency of nth harmonic and lambda n means wavelength of nth harmonic. Fine. Now tell me, V as it is, Fn as it is. What about lambda n? What is the formula? Lambda n equals to 2L upon n. Lambda n is 2 into L upon n. Correct? And now find out Fn from here. Find out. It will be n into V upon 2L. N into V upon 2L. N into V upon 2L. And right now velocity of wave in a given medium is constant. So V is constant. For a given length of the string, L is constant. So the way you will change the values of n specifically, frequency values will also change specifically. So here you can say frequency is also getting quantized. Okay. In the given length of the string, you can have stationary waves with specific wavelengths only. You can have frequency of waves changing specifically according to this formula. Got it? Fine. Lambda n equals to 2L upon n and Fn equals to n into V upon 2 into L. Correct? Wait. Just take n equal to 1, 2, 3, dash, 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 1 by 1. Okay? Put n equal to 1. Put n equal to 1 here. Put it here. N equal to 1 here also, here also. What will you get? Tell me. F1 equals to V upon 2L. Come on. F1 equals to V upon 2L. Correct? Here, n is appearing in the numerator. And among n equal to 1, 2, 3, dash, 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 1 is minimum. 1 is minimum. Because you are putting here minimum value, this frequency is also minimum. So instead of F1, I am writing F minimum. Correct? Find out. Now come on. This F1 is known as first harmonic. What is it called? First harmonic. And that is minimum frequency. That minimum frequency is also known as fundamental frequency. What is it called? Fundamental frequency. Fine. At that time, what is the value of lambda? I am showing you. Put n equal to 1 here and here also. So lambda 1 equals to 2 into L. Lambda 1 equals to 2 into L. Now here n appears in the denominator. When n you are taking 1, that is minimum among these values. When n is minimum, naturally lambda would be maximum. That's why I am putting here lambda maximum. Correct? Fine. So this 2L value is maximum value of wavelength. Maximum value of wavelength. Correct? So what is fundamental frequency or first harmonic? It is minimum frequency. At that time wavelength is maximum. Come on. Minimum frequency is F1 which is V upon 2L and maximum wavelength is lambda 1 equals to 2L. Got it? Wait. Now instead of V upon 2L, you can write F1. Instead of V upon 2L, when you write F1 here, put it here. Instead of V upon 2L, put F1, then you get n into F1. N into F1. Correct? And come on, instead of 2L, you can write lambda 1. Instead of 2L, when you write lambda 1 here, come on, instead of 2L, when you write lambda 1, that would appear lambda 1 upon n. Correct? So remember, frequency of nth harmonic is n times frequency of first harmonic. I repeat, frequency of nth harmonic is n times frequency of first harmonic. And wavelength for nth harmonic is nth part of wavelength for first harmonic. Correct? I repeat, frequency of nth harmonic is n times frequency of first harmonic and wavelength for nth harmonic is nth part of wavelength for first harmonic. Got it? Fine. Put n equal to 2 here. Come on. Put n equal to 2. 2 will cancel. So F2 equals to V upon L. F2 equals to V upon L. Put n equal to 2 here. So it is F2 equals to 2 into F1. Come on, 2 into F1. Similarly, when you put n equal to here, then lambda 2 will be 2L upon 2. 2 will cancel. So it is L. Lambda 2 equals to L. And when you put n equal to here, you will get lambda 2 equals to lambda 1 upon 2. Lambda 1 upon 2. Correct? When this frequency is twice the fundamental frequency, this wavelength is half of wavelength for the first harmonic. Correct? Come on. This F2 is called second harmonic, and that second harmonic is also known as, remember, it is called first overtone. First overtone. Whatever you say about second harmonic, same word you can use for first overtone. First overtone means second harmonic. Fine. Then we go for n equal to 3. Put n equal to 3 here. Then you get F3 equals to 3V upon 2L. F3 equals to 3V upon 2L. And when you put n equal to 3 here, you will get F3 equals to 3F1. F3 equals to 3F1. Come on, put n equal to 3 here and here. Then lambda 3 will be 2L upon 3. Lambda 3 will be 2L upon 3. Put n equal to 3 here, you will get lambda 1 upon 3. Lambda 1 upon 3. This is called third harmonic, or it is also called second overtone. Third harmonic, or it is called second overtone. Just proceed likewise. If it is fourth harmonic, you can call it third overtone. Say seventh harmonic, you can say sixth overtone. 10th harmonic, you can say ninth overtone. Correct? In short, if it is nth overtone, it is n plus 1th harmonic. Nth overtone means n plus 1th harmonic. Come on, first overtone means second harmonic. Come on, second overtone means third harmonic. Likewise, say nth overtone, it will be n plus 1th harmonic. I written here. Look, nth overtone is n plus 1th harmonic. Correct? Come on, nth overtone is n plus 1th harmonic. Got it? Fine. Now, suppose this minimum frequency is, just assume, say it is 100 Hertz. How much? 100. If this F1 is 100 Hertz, suppose, then put here 100. 100 into 2, that is 200 Hertz. 100 into 3, 300 Hertz. Okay. So what is F1? 100 Hertz. What is F2? 200 Hertz. What is F3? 300 Hertz. What is F4? 400 Hertz, and so on. Correct? Now tell me, how do you get these patterns in the string that is not explained in the textbook? I am showing you. First of all, how to get such a pattern? Correct? This pattern is for n equal to 1. This pattern is for n equal to 2. This pattern is for n equal to 3. But how to get such patterns, I am showing you. First of all, you take a tuning fork having, say, frequency, its natural frequency, we assume 100 Hertz. 100 Hertz means right now equal to frequency of first harmonic. Frequency of first harmonic means fundamental frequency. Whatever is the value of this frequency, with the same frequency you take the tuning fork. Okay? You take tuning fork having natural frequency equal to this frequency. And then after you strike that tuning fork, so its sponges would vibrate with the same frequency, which is equal to F1. And then that tuning fork, if you just touch over here with this string, then this string also starts vibrating with the same high frequency. And when the string is vibrating with same high frequency, it so happens there is one closed loop formed in the string. Fine. Now actually string is only one, but it vibrates so fast that at a time we find it here also, at the same moment we find it here also. Then according to law of persistence of vision, we find as if there is a closed loop. And this pattern you will find as if it is stationary in front of your eyes. That's why the waves produced in this string are called stationary waves. But this sort of pattern you will notice in case of n equal to 1, that is in case of first harmonic. Now, what is second harmonic? Second harmonic is twice the first harmonic. So, if F1 is 100 Hertz suppose, then 100 into 2, that is 200 Hertz, correct? Now, you take another tuning fork having natural frequency 200 Hertz and strike the tuning fork with the rubber pad and touch it over here. When you touch it over here, the string will vibrate in such a manner such that there are two closed loops formed in the string. For n equal to 2, we get two closed loops. For n equal to 3, we get three closed loops and so on, correct? As much is the order of harmonic, that many number of closed loops are found to be taking place here in these stationary patterns. Because these patterns seem to be stationary in front of our eyes, we call such waves as stationary waves, correct? How would you define stationary waves? Now, I am showing you. Resultant waves obtained out of superposition of two waves having same amplitude, same frequency, same wavelength, propagating towards each other, and after losing the property of progression, because they produce stationary patterns in the medium, they are called stationary waves. Resultant waves obtained by superposition of two waves having same amplitude, same frequency, same wavelength, propagating towards each other, and after losing the property of progression, because they produce stationary patterns in the medium, they are called stationary waves, correct? Two waves having same amplitude, same frequency, same wavelength, propagating towards each other, when superposed on each other, they produce some stationary patterns in the medium because they lose the property of progression. Such waves are called stationary waves, correct? Fine. Come on. Now, here in these patterns, we find certain positions on the string which remain stationary, for which the amplitude of oscillation is 0. Such points, such positions where amplitude of oscillation of particle of string is 0 are called nodal points. What are they called? Nodal points. In short, we call them nodes. Come on, nodal points or nodes, they are those positions along the length of the string at which the amplitude of oscillation is 0. They are shown by symbol capital N in the figure. You can see amplitudes of oscillation for such particles are 0. They are called nodes. That's why I am putting N, correct? Here also N, 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 N. Got it? And then you can see in the same diagram, there are certain positions along the length of the string where the particles have maximum amplitude during their oscillation, and those positions at which the amplitude of oscillation of particle is maximum are called antinodal points, or shortly antinodes. That's why I am putting here, look, antinodal points or antinodes, they are shown by symbol capital A. Look, here the particle of string has maximum amplitude. As you move from this point to this point, you can see amplitude goes on increasing, and finally here it becomes maximum. And that very position is called antinode, and that's why it is shown by symbol capital A. Similarly, here these two are the antinodes. Here there are three antinodes. Have you noticed one thing? As many loops, that many antinodes. As many loops, that many antinodes. Look, here one closed loop, then you will have only one antinode. Here two closed loops, so you are having two antinodes. Here three closed loops, so you are having three antinodes. Got it? As many loops, that many antinodes. But how many loops do we have? Equal to order of harmonic. So in these two formula, remember this value of n, it indicates 3 points. It indicates 3 factors. Which 3 factors I am showing you? Interpretation of n, you can make 3 ways. N indicates order of harmonic, n also indicates number of closed loops, and n also indicates number of antinodes. Come on, small n means order of harmonic or number of closed loops or number of antinodes. And have you noticed one thing? Number of nodes is greater than number of antinodes by 1. Here in this figure, number of antinode is only 1, but number of nodes is 2. 2 is greater than 1 by factor 1. Come on, number of antinodes is 2, number of nodes is 1, 2, 3. 3 is greater than 2 by 1. Number of antinodes here it is 3, number of nodes is 1, 2, 3, 4. So what do you notice here? Number of nodes is always greater than number of antinodes by 1. I repeat, number of nodes is greater than number of antinodes by 1. Got it? Fine. So if n number of antinodes are there, what is the number of nodes? N plus 1. If there are n number of antinodes, what is number of nodes? N plus 1. Simple? Fine. Now along the length of the string, at which definite positions will we get nodes? At which definite positions will we get antinodes? In short, we would like to determine the positions of nodes and antinodes. Let us find out those positions one by one. First of all, we talk about nodal points, that is nodes shown by symbol N. Now tell me, nodes are those positions. Nodes are those positions at which the amplitude of oscillation is 0. Amplitude of stationary wave. Amplitude of stationary wave, just now we have seen, it is A dash equals to 2A sine of Kx. Same formula written here, A dash equals to 2A sine of Kx. But if given position is a node, then amplitude must be 0. So amplitude I should take 0, and now find out sine of Kx from here. It will be 0 upon 2A. 0 upon 2A means 0. But from trigonometry, don't you know, sine of n pi is 0. Sine of n pi is 0. 0 equals to 0, sine equals to sine. So these two arguments must be same. These two angles must be same. Kx must be equal to n pi. Kx equals to n pi. What is k? Wave vector. It is 2 pi upon lambda into x. That equals to n pi. Pi ones are pi, getting cancelled. Find out x. It will be n lambda upon 2. X equals to n lambda upon 2. But as you change the value of n, say 0, 1, 2, 3, dash, 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 depending upon that, x value will also change. That's why instead of x, I am putting xn. Okay, n you must write well below x. It is called suffix. Put n equal to 0, then you will get 0. Put n equal to 1, you will get lambda by 2. Put n equal to 2, you will get lambda. Put n equal to 3, 3 lambda by 2, and so on. So at this many distances from left end of the string, in this case, you will get nodes. At how many distances? Come on, 0, lambda by 2, lambda, 3 lambda by 2, 2 lambda, dash, dash, dash. At this many distances from left end of the string, you will get nodes. Correct? Fine. At which positions will we get antinodes? Let us find out. Antinode is that position along the length of the string where you can have maximum amplitude. Correct? Maximum. So this amplitude, now I want maximum. A dash equals to 2A sine of Kx should be maximum. But for that, sine of Kx must be maximum. What is the maximum of sine function? Plus or minus 1. So I am writing plus or minus 1. But from trigonometry, don't you know, sine of 2n minus 1 into pi by 2 is also plus or minus 1. Sine of 2n minus 1 into pi by 2 is also plus or minus 1. Now these two values are same. These two functions are same. So these two angles must be same. Kx must be 2n minus 1 into pi by 2. But what is k? It is 2 pi upon lambda. 2 pi upon lambda into x. Now tell me, pi ones are pi, getting cancelled. Lambda will be transferred here. 2 will be transferred here. Come on. X will be 2n minus 1 into lambda upon 2 2s are 4. X should be 2n minus 1 into lambda by 4. But as you change the values of n, naturally values of x will change. That's why different values of x I want to show by different symbol. That's why I am putting, instead of x, I am putting xn. And you must write well below x, it is suffix. Now put n equal to 1 here, then you get lambda by 4. Put n equal to 2 here, you will get 3 lambda by 4. Put n equal to 3, you will get 5 lambda by 4, and so on. Correct? So at how many distances from left end of the string will you get antinodes? I am showing you lambda by 4, 3 lambda by 4, 5 lambda by 4, 7 lambda by 4, dash, dash, dash. Got it? Come on, lambda by 4, 3 lambda by 4, 5 lambda by 4, dash, dash, dash. Got it? Fine. Now, at this many distances from left end of the string, we will get antinodes which are shown in the figure by symbol A. Now here, this much is the length of the string. It is capital L, which is same. For a given string, the length should remain same, constant. That's why I am putting here also capital L, here also capital L, same length. Okay. Here, only crest. Crest means what? Half of the wave. Crest means what? Half of the wave. And half of the wave should have length, half of the wavelength. That is lambda by 2. If it is only crest or only trough, you can take the length equal to lambda by 2. That's why this length is, come on, lambda by 2. But when you are talking about first harmonic, the wavelength must be shown by symbol lambda 1. That's why I am putting here lambda 1 by 2. Correct? Come on, what about length here? I am showing you. This much is the length, correct, which is capital L. But this is one crest and one trough. One crest, one trough. One crest, one trough. So one full wave. And for one full wave, this much length must be equal to its wavelength, that is lambda. So L equals to lambda. L equals to lambda. But this is the wavelength corresponding to second harmonic. So I am putting symbol lambda 2. Fine. Come on here. One crest means lambda by 2. Correct? And such three parts are there. 1, 2 and 3. So 3 into lambda by 2. Come on, 3 into lambda by 2. But because we are talking about third harmonic, then this wavelength should be represented by symbol lambda 3. Fine. Same length of the string, here it is expressed in terms of wavelengths of different harmonic. This length is equal to half of wavelength for first harmonic. This length is equal to wavelength of second harmonic. This length of the string is 3 by 2 times the wavelength of third harmonic. Got it? Fine. From here, if you find out lambda 1, come on, will it not be 2L? Here it is. Lambda 1 equals to 2L. Correct? Come on, find out lambda 2 from here. Lambda 2 is L. Lambda 2 is L. Got it? Come on, find out lambda 3 from here. It will be 2L upon 3. Come on, lambda 3 is 2L upon 3. Simple? Fine. Now, if somebody is asking you, what is distance between two consecutive antinodes? Same is the distance between two consecutive nodes, but how much is that distance? Very simple. Distance between A and A, I am writing AA. Correct? Distance between N and N, I am writing NN. NN. This is distance between two consecutive antinodes. This is distance between two consecutive nodes. But how much is the distance? Very simple. This distance you can see it is one crest. One crest means what? Half of wavelength, that is lambda by 2. So I am putting lambda by 2. Correct? In first harmonic it is lambda 1 by 2. In second harmonic it is lambda 2 by 2. In third harmonic it is lambda 3 by 2 and so on. Simple. So distance between two consecutive antinodes or two consecutive nodes in any harmonic is half of wavelength of that harmonic. Half of wavelength of that harmonic. Simple. But now if somebody is asking you, what is distance between antinode and node? Two consecutive antinode and node, that distance is half of this length. One crest means lambda by 2, its half means lambda by 4. That's why I am putting here AN. That is distance between two consecutive antinode and node. It is half of lambda by 2. That's why it is lambda by 4. Correct? Distance between two consecutive antinode and node is lambda by 4. Correct? One more thing. Have you noticed as you move from node to antinode, come on, amplitude goes on increasing. Amplitude goes on increasing. And as you move from antinode to node, come on, amplitude goes on decreasing. Amplitude goes on decreasing. Correct? Finally, at this nodal point, amplitude will become 0. Simple? Fine. I repeat two things. Come on, what is the interpretation of N? In these two formula, what do you mean by N? N gives, come on, first order of harmonic, Second, number of closed loops. Third, it gives you number of antinodes. If number of antinodes is n, what is corresponding number of nodes in this case? N plus 1. Got it? Number of nodes is greater than number of antinodes by 1. And second thing, definition of stationary waves. Resultant waves obtained out of superposition of two waves having same amplitude, same frequency, same wavelength, obtained out of superposition of such two waves, after they lose the property of propagation, they produce stationary patterns in the medium. Such waves are called stationary waves. Let me repeat the definition of stationary waves. When two waves propagate towards each other, having same amplitude, same frequency and same wavelength, superpose on each other and produce stationary wave patterns after losing the property of progression. Such waves are called stationary waves. I repeat, when two waves propagating towards each other, having same amplitude, same frequency and same wavelength, superpose on each other, the resultant waves obtained produce some stationary wave patterns in the medium after losing the property of progression. Such waves are called stationary waves. Got it?